On June 17, 2016, the DAO project was hit by a reentrant attack, with more than 3 million Ether coins being separated from the DAO's asset pool. The attacker uses a split DAO function in DAO smart contract to carry out repeated reentry attacks on DAO assets. Constantly separate DAO assets from the DAO's project asset pool and transfer them to their own accounts. How did the leak form? Because the smart contracts can call external contracts or send Ethereum coins, these operations require the contract to submit external calls. So all the contracts outside of the call can be attacked by the attacker using cause hijacked. Has attacked the contract to perform at any position, bypass the restrictions of the original code, thus reentrant attacks. To put it simply, there are two conditions for reentry attack vulnerability to occur. An external contract is invoked, and the contract is not secure. Function calls to external contracts precede changes to state variables. Specifically can be understood from 4 aspects: transfer method, fallback function, vulnerability code, source code analysis. Transfer method. The reentrant attack is sent during transfer operations, whereas the transfer methods commonly used in Solidity are transfer, send, and call. Fallback function. The fallback function is one and the only one nameless function per contract, with no arguments and no return value, and is executed in 3 cases. No function was matched when contract was called. No data is transmitted. Smart contract receive Ether. Vulnerability code. The attacker calls the attack function of the attack contract to simulate the attack, which implements a contract similar to the public purse. Source code analysis. Here we list the vulnerability source code and attack steps, also the key code. How should we avoid it? Use other transfer functions. Use Solidity's built-in transfer function when sending an Ethereum transfer to an external address, and change the state variables first. This way, ensure that the state variables are changed before the transfer operation. Using a mutex. A mutex is the addition of a state variable that locks contracts during code execution to prevent reentrant attacks. Use the OpenZeppelin official library. The OpenZeppelin official library has a security contract specifically for reentrant attacks. For details, please check the official library.
Blockchain security mini course is over. Have you cried or not? Please follow our official website and Twitter.